Hello, everyone. My name is Santosh Borse. I work as a senior engineer at IBM Research. I'm a part of a data engineering team. Our team is tasked with preparing and processing data for large language model pre-training and post-training. I'm also a maintainer on Data Prep Kit, which is a open source project for processing unstructured data. I'm going to talk about that in subsequent slides. Here's the agenda. I have four things to talk about. Talk about the importance of data in large language model training. What are the challenges in front of a data engineering team when they process this large data? And what the solutions are, what tools and methodologies we use at the IBM Research. And talk more about the tools. Let's dive in. You must be aware of current AI model race, right, where there is a new model being released every day, which beats the existing model. And and you see a lot of chatter is about the techniques of model architecture. How big is the model? What is the size of the uh, GPUs, the large cluster, and the money it is required to train that model? However, in reality, data is the one of the most significant and high impact factor for any LLM's quality, which is not being very highlighted much, but it is an underlying fact. We will see what this data means in subsequent slides. The reason data is important is because models are what they eat. Whatever the knowledge we have for these LLMs is extracted from the underlying data. If the data is biased, noisy, or misaligned, the models will reflect those in, in, its, in its output. So in a way, it's a garbage in, garbage out. If you have a data which has a garbage in it, obviously the model will blurt those garbage out. LLMs are the most data-hungry creatures. You see, uh, when GPT-1 was released in 2018, which started this AI race, it was trained on a couple of billion tokens, whereas the most recently released model, uh, GPT OSS 120 billion model, it, it uses 146 trillion tokens. So it's like a multi-fold jump from 2018. And they need more and more data because that's the cap. That's where the quality of the large language model is being decided. But it's not just any data, it needs the high quality data as well. So by exposing model to high quality data, model creates a complex relationship between the data. It understands how human communication happens and subtle nuances of our communication. If the data is lacking those qualities, then obviously the model will not have those qualities. You must have heard this phrase, data is the new oil, right? It signifies the value of data, but if you look at in other way, it also gives a similarities between oil and data, where oil needs to be in its crude form is not very useful. It needs to be extracted, it needs to be transformed, it needs to be cleaned, it needs to be distributed to get a value out of it. Same is true for data. Data in its own original form, in its raw form, is not very useful. It needs to be transformed, cleaned, synthesized, and augmented to get a value out of it. So, and the another reason it says that it's a new oil, because the way oil propelled the industrial and transportation revolution, data is going to, or data is doing that job for the AI revolution. For example, Common Crawl is one of the not-for-profit organization. They crawl the internet and keeps the dump of the crawl data into their archives, which we can go and download. They right now have a petabyte of data. even though the actual data they have is from 2007, and they have real data or the full internet data from 2016 onwards. So we said that for LLMs, it's not just the data. It needs a certain characteristics of a data, and these are the characteristics. It needs, obviously it needs a very high quantity of the data because the models are getting larger and larger. It needs to be very high quality. It needs to be a representative of what is the use case of the model. So for larger model, it is fine because they can ingest more data. But for smaller model, it needs to be a very fine balance of what you can accept as an input. It needs to be a balance of all the languages or whatever languages is desired. It needs to be deduplicated because there's a huge duplication on internet. It needs to be a specific to a domain if the model is designed for a domain. And obviously it needs to be safe and secure because otherwise the model will start doing it the same thing. We say that when we start with the input data, this terabytes of data, we end up removing almost 70 to 80% of data before it reaches to large language model. For example, for Granite model for 3.2 and 3.3, we end up throwing out almost 80% of data before it became ready for pre-training. So processing this unstructured data, these are all HTML, mostly HTML documents. There are other formats also. And extracting information from these documents is one of the important challenge we have. This is a typical pipeline of a data processing where once we have a data corpus, it goes through a series of transformation. We call it transformation, which is takes a data, applies a logic or a processing on top of it, and give it to the next processing pipeline. So, for example, this one is where it starts with the block listing. So, block listing is it blocks all the bad sites because there's a lot of porn content and adult content on the internet. So first thing we do is we remove all such sites or domain or all those URLs which has those words in their URL, and then we deduplicate. Deduplication is one of the very heavy job. You can do two types of deduplication. One is where you can remove the exact duplicates, which is very easy. You just compute the hash, but usually it is not the exact dedupes. There are near duplicates where document is more or less similar, but the couple of words here and there or a few paragraphs or a few lines are missing. And you need to find out what is the affinity between these documents and try to select only the subset of it. At IBM Research, our team is tasked with preparing data for training our own large language model called Granite. So our team continuously looks for a way of finding new data, finding newer processing techniques so that we can bring out a better value data. So here are some numbers in perspective. So this is one of the fuzzy dedupe task we ran. You can see the input data is around 253 Parquet files. Parquet files is a data format created for efficient storage. So when the size is 23 terabytes, when you load it in memory, it is 42 terabytes. After deduplication, there were 5.6 billion documents we were left with and occupied 14 terabytes of storage. So you see there's a lot of removal has happened for this. And with 7,500 CPUs and 56 terabytes of a memory, it took 40 hours to run this job. And all these jobs are not like you run once and then you leave it, because all these jobs has a threshold, and you play with the threshold to see which one gives you a better output. Because you could also filter out too much and then you lose some data, or you can, so there is always a fine balance between what to keep versus what to not keep in all the data transformation. And that's why our team do a lot of ablation studies. It's an experiment where we take data or subset of data and then try it on the smaller model and see what is the effect of that data before before we train the larger model. And we have to do hundreds of ablation studies, because it's like a giant radio where you tune one knob at a time and see what is the effect of it. So here are a list of challenges we have in front of a data engineering team. For example, we need to start with, we need a reliable processing toolkits, because we need to apply a lot of transformations on that data. And how do you get those transformations? It's very important. For example, which algorithm to select for the deduplication, or what is the right block listing, or what is the right hate abuse profanity detector. So we need to select that. Then data locked in complex formats. For example, HTML is one, but as Peter was talking about docking, PDF is another, where there's a huge wealth of data. And we need to extract those formats also, and again with the faithfully, so that we retain the content or the meaning of the document without losing that. Obviously, it's a huge data. It's a terabytes of data. We have to process as much data as we can, because all these human knowledge may be locked into that data. So we are always looking for more data sets. Scalability, we need something which can scale. Obviously, this is a large data corpus, so we need something which can scale the processing. We need a cluster management. Obviously, this will not run on a local machine, so you need a good size cluster to manage it. It needs to have a job scheduling, because the team members who wants to use it and wants to share the system. Ability to develop on local machines. So all these changes you do or transformations you develop needs to be tested locally. Easy to launch data processing job is another, where all the team members, not all team members knows what is going on under the hood, but they need to run that, oh, I want to run this particular transformation, and they should be able to do it without actually knowing the underlying details of the transform. Visualization is something where they should be able to visualize. Chaining data transformation, so you create a pipeline or a chain of a different data transforms, where output of one becomes an input for others. And how do you chain that transformation is very important, because which one comes first and after is very important. So you should be able to play with the combination and see which chaining of the transformation works best for you. Obviously, we need an open source ecosystem, because these tools evolve, and we need to not need to be locked into a specific vendor. And we should be able to switch those tools as we want as well. We should be able to do error analysis and observability. So these are all challenges we have in front of a data engineering team, and we face these challenges day to day. It is one of the hard engineering problem, because the size of the data is so much that when things go wrong, it can go wrong well. Another problem with this is you cannot read the data, because it's so huge that it's almost impossible to read what's being filtered out, and that's why you need a system which can give you a better feedback. And the way we do that is, obviously we do run a lot of ablation studies, as I mentioned before. here are the solutions. So our team dealing with these large data has learned a lot of things, and we have adopted or created these tools to handle the data processing jobs. So unlike traditional data processing jobs, LLMs deal with a lot of data. So there are very well established tools available to do a data processing. It's one of the oldest computer science field. However, that always deal with the structured data where you try to deal with the SQL tables or a defined format data processing, and that too on the smaller scale, maybe in the gigabyte scale. Whereas here we are talking about terabytes of scale. So our first tool we use or a solution we use is a data prep kit. Data prep kit is a data processing toolkit. It has around 40 plus data transformations. For example, there is a transform available for processing, for removing duplicates. There are transforms available for removing hate, abuse, and profanity. There are transforms available for doing a block listing and document quality. For example, what document quality does is it analyzes the document and gives you a score of what is the quality of the document between 1 and 10. 10 means very high quality, whereas 1 is low quality. And then you can decide what is the filtering criteria for that, and based on that, you can do a filtering. I'm also a maintainer on Data Prep Kit. It's an open source project, and we are looking for a contributor. So if you want to contribute to any open source project and interested in this area, please feel free to try. Along with the data processing toolkit, we also need ability to scale, because it will take hours and hours or days and days to run it on a smaller machine or a small cluster. So we need to be able to scale the job, and that's why we use Ray. Ray is a very nice scalable platform where you can run the same transform on local machine and may use one single CPU on your local machine or multiple CPUs on your machine, and the same job you can run it on a larger cluster. In Ray, you don't have to start and stop the Ray cluster if you are doing a local development, whereas in cluster, it can be managed by the other tools. Another tool we have is a dockling, which Peter just spoke about. Is we use it to extract the PDFs or the different documents format. It has a OCR support and very high quality understanding of the PDF documents. We have a other extractor as well, which extract from HTML and Markdown and a different formats. There are different parsers we have, which parse those documents, keep it ready for the data processing. And Data Prep Kit has those parser as one of the transforms. So you'll see there is a transform for the dockling. Obviously, all these things needs to be run in a cluster. And what is better option than Kubernetes to run these jobs? So everything, all these data processing jobs runs on a Kubernetes. Obviously we have a very large cluster. What Kubernetes offers is a seamless management of a cluster where we don't now need to think about scheduling and resource sharing and all other problems. So it gives us observability also to see, okay, which nodes have a problem, what can be, where is the resource crunch. It gives us auto scaling where it can scale a job automatically for us. And another tool we use is a Kubeflow. It's a pipeline creator tool where you can create a different pipeline where transform becomes one single pipeline, and you can chain those pipeline to create a nested pipeline. It gives you a nice visual representation where you can go and launch different jobs or see what jobs are running, what resources they are consuming, or what was the configuration on those jobs. It has you can go and see the error in the visual area itself so that you don't need to go on the Kubernetes cluster. It also has a fault tolerance, and you can create nested pipelines where you can chain different pipelines together. And then whole organization can have a unified UI where you can look what jobs are running and then spawn your own job based on what's running versus what's not running. All of these are obviously an open source project where you can go and contribute to, and all of them are really cool projects. More about Kubeflow Pipelines. So this is how it looks, where you can see a job, it's running, and then you can see boxes is one single transformation or a execution, and then you can chain them together to make your processing flow from one place to other. You can also create a branching where there are two parallel jobs happening at the same time, and then a merging where their outputs is coming together. Okay, I don't know what happened, but this is okay. I think some automation happened here. Okay. So so this is a single pipeline where the way it starts is when you invoke that pipeline from the Kubeflow UI. What it does is it creates using Kubeflow, it creates a KubeRay custom resource definition in a cluster, which starts a ray cluster. The way ray cluster starts is it creates a number of pods, and in that pod it starts a ray actors. And then the job is being executed by those ray actors, utilizing the Kubernetes way of scaling and job management. Once the job is done, the management Kubeflow management operator stops the job, stops the ray cluster, and frees up the resources. Okay? So this is how the single step pipeline look like, where you start and see what are the resources required, then start a ray cluster, execute a job, and stop a ray cluster, where these are all the shared components being used by all the jobs, right? So all jobs more or less look like this. They bring up a ray cluster of a different size, then execute a job, and then bring down the cluster. The multi-step pipeline looks similar to a single step, where now they are chained together, where the output of first becomes the input for the second. And it works similar to that, where now all things happens one by one, and you are able to see which stage your data processing edge, which pipeline is being run, and how long it takes, and then you can go in a UI and see the logs and monitor the job. All of this happens on a local Kubernetes cluster, and there can be multiple jobs running at the same time. So switching back to a data prep kit, which is I'm a maintainer on. So it's a open source project. Recently, we donated this project to Linux Foundation, and we are actively seeking contributors. It's a data processing toolkit for processing large unstructured data. You can use it for processing data for pre-training, which is a very large training usually. And you can also use it for fine-tuning, which is a post-training where you actually deal with the much smaller data. You can also use it for RAG pipelines, and there are demos available on the GitHub page, which goes through the RAG and different pipelines. We have a buffet of transforms. So there are, the power of Data Prep Kit is in its transforms, because we have so many transforms that it allows you to pick and choose the existing transform instead of developing them. And all these transforms are being used by us at IBM Research. That gives them a credibility that they are being tested in the real world use case. Along with the existing transforms, the framework allows you to bring your own transform as well, where if you think that something is missing or something is not fulfilling your use case, you can inherit the existing transforms and modify it, or you can write your new transforms, which then you can contribute as well. Here is one example transform. So, and there's a link to that. So it does a RAG with a Data Prep Kit. So the way it does is it starts with a PDF extraction, and then creates a embedding and loads it into a vector database, and then you can question your vector database for the RAG use case. For dockling, we have two transforms, dockling to Parquet. So first, it converts the PDF files to a Parquet file, and Parquet file is the format which we use in DPK to input and output. So it makes it ready for all other transforms. And then in that chain, you can put in any data transformation. For example, removing a duplicates, or removing hate, abuse, profanity, or removing any unsafe content, or you can plug in your own transformation as well. Here are the different demos we have on Data Prep Kit. So there is a cool app called AliCat, which is built on top of a Data Prep Kit. It is a more elaborate use case of RAG. There is a fine-tuning notebook which fine-tunes your model for a language use case. So if you want to fine-tune your model for a Python or a Java or a specific code data set, you can do that. We also have a NiceWeb. NiceWeb is our pre-training data set released by us earlier this year. It's a openly available data set with the recipe. So you can go and see a recipe. So we started with the fine web, which is already a high quality data set. And then we reduced that to 10 trillion token. So fine web is around 15 trillion token. We reduced it to 10 trillion token. And we showed that even reduction of 20-30%, we were able to improve the quality, improve the metrics of evaluation, where model with the new data performs better than the actual original data, even though the quantity of data is reduced. And that also proves that the quality of data is extremely important for large language models. Very important for me is we are looking for contributors. There's a lot of interesting transformations we have, and we are looking for more use cases. There are a lot of issues we have. We want a support from the community, and it's a relatively new project. So anybody who wants to contribute is very welcome. Please get in touch, and we would appreciate if you give a star on a GitHub. And I think that's all.
So, Santosh, thanks for the presentation. Quick question I have. This might be a controversial question, but so have you actually done experiments where you train without deduplication and without all of the, just take the web as is, no hate, profanity, we don't care, you're not duplicated, and actually see what happens and what the ultimate outcome is compared to adding all of these things, because not that you want to roll that out, but just to actually see what is the ultimate influence of that one.
Right. So yeah, actually I started that project a few months ago. It's called Evil Model, but I should not talk about that. It's my personal thing which nobody knows. You guys know, but don't tell anybody. Right. So there are, obviously we have to play with these removals, and even with all these removals, all these processing we have done, we have seen in earlier versions of a model where it starts saying something bad, right? The F word, it started using it for very simple conversation. It just blurt out that, right? Now that may not be very important for regular company or a company which is very new, but for IBM it is extremely important. For IBM it is extremely important that we don't give any wrong information. So for us the processing is very strict because we want to be on the good side of the output and not on the other side, even though maybe other side having been training with more data maybe makes model more creative. Another thing with, and there are like millions of problems with this, is having all the data. What does that do is, because there is a lot of duplicates, now your model is overtrained on that, and because it is overtrained on those duplicate data, it is undertrained on the real data. So then it knows few things very well, but not everything. So there are a lot of problems, and that's actually the engineering challenge, is to how do you walk a fine line between not removing too much and not having something bad, and we always have to balance that very well.
Hi, so I just have a quick question about would you consider cost be one of data engineering challenge, and how do you guys balance efficiency and affordability?
Right. So yeah, obviously, cost is very important, and I think I should put that in my challenges, because, um, and his question was like that, right? If you train with all the data, what will happen is your training time will increase, right? And if your training time will increase, obviously, then you will be consuming a lot of GPUs power, and then you'll need a bigger data center to train, and that translates into the actual cost, because one of the highest cost of these model development is the training, the cost of GPUs. So if you have too much data, that to a bad quality, then you are ending up spending more time in training and more money on the training. So cost is a very effective, and that's why we want to create a very high quality data where model will be able to learn things with this less data than the more data, because more data will be translated to more GPU consumption. Thank you, everyone.